to search for different aspects in the data. Next, the output layer, which provides a final prediction based on the model insight by utilizing data from previous hidden layer. The most important stratum yields the outcome. Next, LSTM for neural network. In this, we have two problems to discuss: vanishing gradient problem and exploding gradient problem. A significant challenge in training large neural network, particularly those with several layers, is the vanishing gradient problem. It happens when gradients calculated during backpropagation get smaller as they pass back through the network, making it harder for the layers that came before them to correctly learn and modify their weight parameters. The problems could emerge for a number of reasons are mostly activation function, weight initialization, extended chain, extended chains of multiplications. Activation function. When the magnitude of input rises, the gradient of activation function may appear to vanish quickly. Example, the sigma and tan h functions. Weight initialization. In order to further minimize the gradient during backpropagation, a network with modest beginning weights may learn more slowly. Extended chain of multiplications. In massively multi-layered deep networks, gradient may be often multiplied by minuscule values, which may ultimately lead to their fast disappear. Next, exploding gradient problem. For this, an analog problem to the vanished gradient problem is bursting gradient problem. It is when backpropagation gradient, which are computed at every larger values, reappear across the network. A number of issues may arise from this. Firstly, instability caused by weight. If weight updates are too large, the network may become unstable and divide. Saturation. When the activation function of the network approaches their maximum or lower value, they become less sensitive to further change in inputs. We refer to this as saturation. Next, NaN, non-numeric values. If the gradient overflow, they may result in non-numeric values, which would make the network unusable. Erroneous activation functions and weight initialization are two factors that are similar to those that produce the vanishing gradient problem and blowing gradient problem. Moreover, the gradient may get increasingly amplified by recurrent connections across the network, impairing it. Next, these are the gradients. problems. You can see the vanishing gradient and the exploding gradient. From input layer to the output layer, how is the gradient fluctuating? Next, the limitations of simple RNN neural network. The simple RNN design is widely used in recurrent neural network. It has few shortcomings. Firstly, short-term dependencies. One of the simple recurrent neural network main application in data analysis is the efficient identification of short-term relations. Because of the vanishing gradient problem, they had difficulty learning and retaining information over extended period of time, which make it difficult for them to do complex tasks requiring long range context. Next, information bottleneck. The size restriction of the hidden state in simple recurrent neural network may result in an information bottleneck. This bottleneck hinders the network capacity to store and manage long-term dependencies effectively. Next, sensitivity to initialization. The initial weights of the network may have an impact on SRNN. Inadequate initialization can exacerbate the vanishing gradient problem and reduce the network's learning capacity. Next, the LSTM neural network and gradient problems. To get around the problems with SRNN, a neural network known as long short-term memory is created, included to help with fixing the fading and expanding gradient difficulties. These are the crucial components which we can use. Gate structure. LSTM utilizes a variety of gate topologies, including input, output, and forget gates. Because these gates control the flow of information throughout the network, it can selectively remember and forget information over long duration. Next, cell state. Long-term memory consisting of unique cell state that stores information for a long time. The SRNN information bottleneck issue is resolved. Non-linear activation function. LSTMS commonly utilizes non-linear activation functions such as tanh or ReLU activation functions due to their superiority gradient properties compared to sigma tanh functions used in gradient problem and reduce the network learning capacity. Next, this is LSTM recurrent unit. In this, you can see cell state, hidden state, where the forgot gate, input gate, and output gate are sigmas, and candidate for cell state updates are tanh. At last, the updated cell state to help determine new hidden state. This is LSTM for recurrent unit. Next, now we're gonna discuss on LSTM with time series data. In this, we're gonna discuss on time series data. A structure of neural network include the quantity and type of the layers. The number of neurons in each layer and the connection between the layer.